Hello everybody, Algebra Skills and Geometry Foundations lesson number 2. Here are a few of the things you'll be able to do by the end of this lesson. You'll be able to name and label an angle, measure and create angles using a protractor, recognize and label congruent angles, and define and label an angle bisector. Let's go ahead and get started. Okay, a basic angle is formed by two rays that share a common endpoint, provided the two rays are non-collinear. So we can see that we have a ray here, BA, and a ray here, BC. This angle is named angle ABC or angle CBA, as you can see written here in purple. Notice that B is the center letter on the angle's name. That letter represents the vertex. The vertex is the common endpoint of the two rays that create an angle. When naming this angle, you use the angle symbol and then three letters. The middle letter, as said before, is always the vertex, and the other two are points on those subsequent rays. Name the sides of the angle above. So the angle above is created by ray BC, which is this ray right here, and ray BA, which is the ray noted in blue. Okay, let's continue on to the next topic. In some situations, we can name angles with numbers. Now, in this case, angle JKM, as we have here, can also be named angle 1, or the other orientation of the angle, which would be angle MKJ. Those would all represent the same equivalent angle. Angle MKL can also be named using angle 2 or angle LKM. In some cases, we can use just one letter to name an angle. That is when there is only one angle coming from a specific vertex. So up here at vertex K, you can see right here, vertex K has two angles coming from it, angle 1 and angle 2. But in the diagram below, angle ABC has only one angle coming from it. It would be this angle noted here. So we could call this angle ABC, angle CBA, or just angle B. In this situation right here, there are four angles located at that vertex, vertex being whatever letter we want it to be. Therefore, this scenario would require three letters to name any of those four angles. We could not just use the letter W, because then we wouldn't be able to signify which of those four angles we'd be referring to. Okay, let's continue on to the next topic. All right, measuring an angle. Measuring an angle, the smallest amount of rotation about the vertex from one ray to another. Okay, in order to measure an angle, we place the angle, which I will do right here, and we take that angle and we put its vertex, let's call its vertex B. We're going to put its vertex right here, and I'm going to have to, just because of the recording, I'm going to have to estimate what this would look like. And I take this angle here, putting the first side, we'd call this the initial side, along this axis, and then the terminating side somewhere up here. And now this is how we would measure the angle's measurement. We want the smallest angle of rotation. So I want to know how many degrees must we rotate the red line in order to attain the terminal side, that blue ray. Okay, so I would look at the inner numbers. You can see 0, 10, 20, 30, 40, 50. Now don't work on the outside numbers, as this wouldn't make sense anyways. This is an acute angle, so it should be less than 90. I would approximate that the measure of angle B is about 48 degrees. Okay, I would do the same thing over here on the obtuse angle. I would take the initial side, okay, which would be this side right here, and the terminal side, which would be this side right here. And I want to find the angle of rotation. And if I were to estimate where that would be, okay, I would guess, this is a total guess, but I would guess that that terminates somewhere in the area of right about here. That's a guess, okay? So that would be, I would say, about, again, if I put B, the vertex, right there in that circle, I would guess about 125 degrees. Notice, as I'm counting, I continue to use the inner ring of numbers. I get to 110, 120, about halfway to 130, that'd be 125. And of course, we know that a right angle would be 90 degrees. So the angle of rotation from the initial to the terminal would end up lining up perfectly with the top of the protractor. Okay, let's continue on to the next slide. Okay, note, assume that angle SCT has a measure of 31 degrees. If we wanted to state this, we would write the measure, M is for measure, angle measurement or angle symbol, SCT is equal to 31. M is for measure. We say the measure of angle SCT is then 31 degrees. If we have congruent angles, these are angles that have the same measurement. Notice the hash marks here. Angle ABC is congruent to angle XYZ. I could also say that angle B is congruent to angle Y. Now let's go back to our lesson from the day before. Remember, objects are congruent, whereas measurements, they are equal. Angle ABC and angle XYZ are objects, so we're going to state congruence there. Measure of angle ABC and measure of angle XYZ would be equal. Objects are congruent, measurements are equal. Let's continue on to the next slide. Okay, how to draw an angle. We want to draw a ray. Look at that, I drew a ray. Let's call this ray BC. Okay, step one, check. Place the crosshairs of your protractor on the start of your ray and set your ray at 0 degrees. Okay, so I would translate this to look somewhat like this. Let's consider that I actually did that correct. Mark a dot at the desired measure using the same row of numbers used in step 2. Okay, so let's say I want an 87 degree angle. Well, I would measure out 87 degrees on the inner portion, 87, so that would be right about here. I'd put a dot at 87, and then I'd connect. Okay, what if I did a ray the other way? Let's go ray B, BD. Okay, and I wanted a 123 degree angle. Well, I would follow the outer numbers now. So if my ray points to the left, I follow the outer numbers out to 123. Right there, I put myself a nice little point there, and then I connect. This angle right here is 123 degrees. This black angle right here is 87 degrees. Okay, we draw our second ray, starting at the vertex and going through our point, and we've got ourselves the angle measure of desired length. Measurement. All right, let's continue. We've got a couple more slides. An angle bisector is a ray, a line segment, or a line is an angle bisector if it contains the vertex and divides the angle into two congruent angles. Okay, so right here, I've got ray AT. Ray AT. It is an angle bisector because ray AT bisects angle MAH. Right? It splits MAH into two angles of equal measurement. So it splits it into MAT and into angle HAT. And if the measure of angle MAT is equal to the measure of angle HAT, then we have what's called an angle bisector. Okay, so ray AT is an angle bisector, and it's because it attains this property right here, right? It makes the measurement of the two new angles equal to each other. Another way we could write that is angle MAT is congruent, right? Because these are objects now, to angle HAT. All right, guys, that's it. We will see you in lesson 3. Have a great day. See you in the next video.